This video will decode the functional language of engineering, from design to operation, focusing on piping and instrumentation diagrams, or P&IDs. These diagrams are the lingua franca of process plants. A P&ID is a schematic, unscaled drawing that illustrates the functional relationship of piping, instrumentation, and control equipment. It is essential for design, procurement, construction, and operations. P&IDs are the most detailed of the three core diagram types. The block flow diagram shows the concept and main process paths. The process flow diagram shows the flow, major equipment, and operating conditions. And the P&ID details the control logic, piping, and instrumentation. A P&ID focuses on physical connectivity and shows piping and control logic. However, it is not a wiring diagram that shows wire terminals, nor is it a logic diagram that details Boolean control logic. While companies have unique libraries, ISA 5.1, or ANSI/ISA 5.1, is the universal baseline for instrument identification. It is the primary dictionary for North America. Other standards include ISO 10628 and IEC 60617. Instrument tags like FIC 101 are decoded by looking at their letters and number. The first letter denotes the variable, succeeding letters denote readout and output, and the number is the loop number. Essential instrument symbols include circles for discrete instruments and diamonds for PLC functions. A missing line means the instrument is field-mounted, while a solid line indicates a primary location like a control room. Line and signal symbols include a solid line for process piping, a broken line for electrical signals, and dashed lines with X's or circles for pneumatic signals and data links, respectively. Various symbols represent valves and actuators, such as the bow tie shape for a gate valve, a similar symbol with a dot for a globe valve, and a more complex symbol for a control valve with an actuator. The human-machine interface, or HOA switch, can be hand, off, or auto. The auto position is PLC controlled. The associated interlock symbol, a diamond with an eye, represents safety logic connecting the switch to the motor. A control loop follows a feedback cycle: measure, decide, and act. The sensor is the eye, the controller is the brain, the actuator is the hand, and the process is the result. Basic loop examples include pressure control, aiming to maintain tank pressure using a pressure indicator and controller, and flow control, aiming to maintain a constant flow rate using a flow indicator and controller. Advanced loops include cascade control, where the output of one controller is the input for another, and feed-forward control, which adjusts based on the input load rather than the resulting output. A practical application is a pump station. The process involves sensing the level, comparing it to a set point, adjusting the pump speed, and monitoring the resulting flow. The P&ID is the active governing document for process safety across the lifecycle. It serves as a key milestone document during design, construction, and operations, aiding in control logic, installation, and management of change.